Alright, good day, student. What we have is mechanics. You are given to resolve force 6 T and the F. This diagram came from a sentence equation. One end of the string is fixed to a point Q, as you have seen, and the other end is hooked to a block of mass 15 gram. When a horizontal force F is applied to the block, the string is inclined at an angle of 60 degrees to the vertical. If the system is in equilibrium, calculate the tension in the string. And also the horizontal force F that used to pull the string. Take G to be equals to 10 meter per second squared. Alright, to solve this type of problem, you can do it in two ways. You can resolve forces vertical and horizontal. You can as well use a theorem we call Lamens theorem to solve the equations. So in this case, we are to make use of Lamens theorem to solve this problem. So what is all about Lamens theorem? Lamens theorem states that when three forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the other forces. That is what it stated. So in this case, let the three forces be. We can assume let the three forces to make use of this Lamens theorem. Let the three forces be S, Y, and the Z. So according to Lamens theorem, you say that they let me repeat it, state that when the three forces acting at a point are in equilibrium, he said that each force is proportional to the sine of the angle between the other forces. So in this case, we have x divided by sine theta x. Let this the angle be the angle facing x, opposite the force x. Then y divided by theta y, which is equals to z divided by sine theta z. So Lamens theorem can also be stated that when three forces are at equilibrium and acting at a point, each force is directly proportional to the sine of angle opposite it. So in this case, let us come to this point. Let us resolve the find the angles facing that is opposite each force. So in this case, we have to, as we have seen, this is perpendicular. All you need to do is to draw another perpendicular line here. Draw a horizontal line so we can resolve the angles. Notice that this angle here is equals to this angle, that is alternate angles are equal. So this is 60, here is also 90. So summing the two angles, we have what? 60 plus 90 will give us 150. So the next thing has to do is, we know that this sine means 90 degree, which is perpendicular. So this angle is 90 degree. If here is 60 degree, this angle is 60, the remaining angle will be 30, and here is 90. So that if you sum the two angles, you have 120 degree. So you see, by using Lamens theorem, we can now apply it here. That the force, if three forces are at a point, in this case, this is the point, each force is directly proportional to the sine of angle opposite it. Opposite is moving here. This is the angle, sine of angle opposite it. So let's substitute it here. Let us substitute the what I have stated. In this case, we have F divided by sine what? Sine 120 is equals to, this is 15G. That is 15 times G. In this case, G is 10. So times 10 divided by the angle facing it, opposite it. You see, this is the angle opposite it. So So sine what? Sine 150. Can say opposite it or facing it. You see, this is where it is. This is the angle. So if you're moving this way, the angle is here. So that is it. What day is set directly proportional to the angle opposite it, or directly proportional to the sine of angle between other two forces. Between other two forces. Look at one force here. This is another force. It's directly proportional to the sine of angle between other two forces. So if this is one, this is another two force. Directly proportional to the sine of angle between other two forces. So here we have what? 15 times 10 divided by sine 150. Then the next is this angle, this tension, which is T divided by sine 90, because sine 90 is between 15 gram and the force F, horizontal force F. So once we have written it, the next thing is to use the knowledge of ratio to solve for the F and the T. So from here, let's first, we know one ratio, so let's use it to find the value of T. So this implies, is the first question asked. The first question say that tension T in the string. Calculate the tension T in the string. Alright, so from here we have T over sine 90 degree is equals to 150 divided by sine 150. And when you use your calculator, you will see that sine 90 degree is equals to 1. So since sine 90 degree is equals to 1, this is like dividing by 1. And any number divided by 1, number of variable divided by 1 is still the number of variable. So this is equal to T. In that case, T is equals to what? 150 divided by sine 150 degree. So find the value of sine 150 degree. That is the same as 150 divided by, if you find the value here, because sine is positive in the second quadrant, you have 1 over 2. In that case, you have 150 multiplying by 2. So that T is equals to 300. T is equals to what? 300 Newton. So you come to this place and put it. T is equals to 300 Newton. The next thing is to find the value of F, that is the horizontal force acting on the, that pull the string horizontally. So let's click here. So question 2, which is B, in this case you have F over sine 120 is equals to 150 divided by sine 150. So we have solved this before, since it is equals to 1. So this is the same as 150 divided by sine 150 is 1 over 2. And when you solve the fraction, as we have gotten T, we have 300. So the next thing is to cross multiply. If you do it, you have F to be equals to 300 sine 120, and that gives us 300 times what? Root 3 over 2, and that gives us what? 150 root 3 Newton. So in this case, the horizontal force is equals to 150 root 3 Newton. That is it. You can leave it in this form, or you can put it in decimal form. So this is what you are required to use for your views. Like and share, click the notification button whenever I have no update. You'll be the first person to be notified. I hope you enjoyed this video. See you in the next lesson. Bye for now.